Hi everyone, welcome back to Physics Screencasts. Today what we're going to talk about is one of the key skills that you need to have in order to deal with situations where a couple of forces or more than a couple of forces are pulling on an object all at the same time. The biggest thing I'm going to show you is a tactic called free body diagram. And free body diagram means that you just isolate the body, you free it from all the other things that are around, all the surroundings, and you focus your mind on the most important thing, just the object itself and the forces that are pulling on it. And so what we're going to just do is work through an example here that you've got in the workbook on page A-35. Here we have a 10 kilogram sled that's being pulled by a force of 100 newtons. So you can see what I did was I put a pulling arrow going to the right, just like they told me to, and at the same time I put a pulling arrow going to the left that's equal to 60 newtons. Now, one of the things that's going to be really important for us to do is, and this is a suggestion probably more than an actual rule, but that is to remember that there can always be a minus direction. And that's why I write my diagrams like a tug of war as opposed to a push of war. So when I see a force pulling to the right, I put it on the right-hand side of the picture. And a force going to the left, I put it on the left-hand side of the picture. And the beautiful thing about that is that that always simplifies my life, because if you remember all of our work on motion, everything in terms of motion that was going in the right-hand direction we called the positive direction, and everything going in the left-hand direction we call the negative direction. And what that does is it makes it really simple to figure out the net force. And you're going to see me for the first time right now write down a symbol that's we're going to use a lot. The net force is how much the winner wins by, or it's equal to the sum of all the forces. So sum of all the forces means 100 newtons plus, and because I drew the diagram in a way that I was mindful of the minus, minus 60 newtons, I end up with a net force of 40 newtons. And that's going to make it really easy to use this thing we call Newton's second law to figure out the acceleration of the object. So I've got 40 newtons equals mass times acceleration. So mass we knew was 10 kilograms times acceleration. And we'll do a little algebra and come up with acceleration equals 40 newtons over 10 kgs. And boom, there we are. We get 4 meters per second for the acceleration of our sled. Okay, one more and we'll be good. In this question, we have to supply all the diagram. So we get a 1,500 kilogram car, and it's propelled by a force, and they don't tell us in what direction. If the force of friction due to air resistance is equal to 200 newtons, and they don't tell us the direction, they're going to ask us the car's acceleration. So this is where it helps to have a little bit of experience. You can draw awesome cars like I do, or you can draw a brick with wheels on it, or you can just draw a brick. But one of the things that I always do, just out of habit, is I make my cars facing in the positive direction, and I make the propulsion force go to the right, so I know that it's a plus force. And that way, since I know that the force of air resistance always fights the motion of a car, I'm going to put it back facing in this direction, and that means it's a minus force. That way, when they ask us to go and figure out the car's acceleration, I'm going to use my Newton's second law, sum of all the forces equals ma, to go ahead and add up all the forces, 2,000 newtons plus minus 200 newtons equals ma. M is 1,500 kilograms times A, and I'm just going to sweep up all my information here and see what I'm left with. So this looks like 2,000 minus 200 looks like 1,800 newtons equals 1,500 kilograms times A. So A is equal to 1,800 newtons over 1,500 kilograms, and that's equal to 1.2 meters per second. And there you go. So 2 examples to get you on your way. Have a nice day. See you soon. Bye-bye.